Good afternoon, ladies and gentlemen. It's a great honor for me to be here to talk about GIS digitizing. First of all, I want to show you the intro and intermediate courses that I put into 4 parts. Mainly that part 1 and part 2 is in intro level, and the intermediate level for GIS will be part 3 and part 4. So let's look at how digitizing fits into the GIS environment. And now we can see that GIS for the digitizing it fits into part 2. And today we are looking at the digitizing in part 2. From each of the main part, we have different tasks. Okay, and digitizing is one of the tasks within it. The objectives today that have the objectives for digitizing have 2 parts. The first part, of course, is talking about topology. Today, we only focus on how to add features, about digitizing, how to edit maps, how to create a feature, how to edit the features, and some of the tools to help us in digitizing. The first outline shows you in the next 30 minutes what I'm going to talk about. First, I will explain why do we have to digitize and what is digitize, okay, and some of the methods. So the methods, I name it the old way and the new way. So the old way, also known as like heads down, and the old way, the old way is heads down, and the new way is heads up. Very easy to remember by the end of the courses. If you don't remember anything, at least you know the methods for digitizing. You have heads down and heads up, the old way and the new way. So the old way being heads down and new way being heads up. And editing. So using the heads up digitizing, how do we do editing, and some of the common tools that are very useful to do digitizing. And finally, we will go over some of the transforms and adjustments that once you have different data sources, how will you, some of the concept for transforming and adjustments. The first question was that why do we digitize? There are several reasons that we do it. Sometimes you want to create new maps or new features. Sometimes the map features are wrong. There are some errors there. You need to correct it. And there are some missing features. There are some other issue. For example, that editing can help update existing feature class or created ones. If a house subdivision is added to a city, or we can say building B is expanding, or the FCJ, some building is expanding, that we need to add some of the new roads, new puzzles and sewer lines, or maybe new parking lot you need to add to the database to ensure it's up to date, and the city planning or architecture or facility planners need the GIS data. So that's why we have to go into to edit and either creating some feature or add some feature to fix some of the issue. Another example we use every day is the road construction. So, for example, a road is under construction or new roads added to your neighborhood. So, even a new exit on the highway and a new lane is added. So here on campus, even the bus schedule changes that you want to update it. Of course, a lot of company does that so that once you search on your cell phone, that's how you get your information. Okay, the old way, okay, is the heads down digitizing. So digitizing will use a tablet, and basically your heads is just focused on the taped map. So you tape this map to the digitizing tablet, and you have to register some of the control points, and the two conversion equations are used. We have vertical and horizontal coordinates. You digitize some of the features there. So this method was heavily used during the 1980s to 1990s. They have to produce some of the soil maps back then, and they trace the features. It's very time consuming, and sometimes it could be painstakingly detailed work, and maybe people could make mistakes that the manually digitize. So back then, if you want to use the soil survey manual, it depends what level of accuracy you expect at that time. So there were some limitation there. So move on to the new way, the heads up digitizing. Your head's being up because you use the mouth and you are facing the screen. So instead of you looking down a little bit and your head is facing up a little bit. So what you digitize is the machine. The technology advancement allows us to scan those paper and import it, the remote sensing data, aerial photos, or other images, so that we will allow us to go into create or digitize the features based using those base maps on the computer screen. And the tools are available for us to do a better job. So now we're going to talk about editing. So first, before you edit, you have two scenarios. The first one is you already have a feature to work on. Some work already being done, and then if you do not have a feature, you just start from scratch, then you have to create some new features. So before you create new features, you have to do some spatial thinking. Do I have to create some points, lines, and polygons? What features you want to represent in the real world? For example, I have a bus stops to create on our campus. So then I will create points, each points that represent one bus stop. Okay, one bus stop. And the bus route that I can trace in the line from point A to point B. So for example, the route, bus line that goes from the main street and Laura Street, and then it will go to Pearl Street. So the lines will represent the bus route, where it's gonna go. And for the commercial zones or our parking lot or our buildings, then we can create polygons to represent those features. So to create features that we need to on our database, we could on our folder that where you store your file, that you could create a geodatabase within the Arc catalog. So in the Arc catalog, once you create features, you right click on the geodatabase and identify what kind of feature do you want to create. Either points. So if it's points, you can see the points on this little icon, lines, and polygons. So once you have those features, and then you go into there is a tab just for editing. So then you go to this Edit tab. Under Edit tab, in the features, there is a Create button. Once we click this Create button, a window will pop up. So this is called Create Features window. So once you create the feature, you drag it into map, contents of map, nothing shows up until you create the feature. So that, for example, that I could do is that if I want to work on the bus station, I select bus station here, and then this icon selection, you click select, and you click the parking lot either on the contents pane, or you can do it in Create Features. So once you're ready, then then the construction options will opens up. And then you go into this map view and find the features on the map. Okay? So now let's go into detail and see how would you create a new point features. To create a new point features, once you in the create feature pane, that you clicked what kind of feature would you like to create? Maybe just line, or you want to have a different nodes. Okay, here or multi points. I just have a 1 point in, so that I would click where the bus stop on the map. So once you click in a sequence, one point that represents a bus stop, okay, and then the corresponding feature will show up in an attribute table that relates to the feature. For example, the object ID 1.z that will link to this bus stop, and point 2, the same way. Once you second click on the map, that a new feature, a new attribute records will be added as a new row. It corresponds on the map for you. So that allows us, for example, Google Map. You want to find the nearest bus stop. And the new column added, it will tell you, okay, this is the red line, and bus stop 1, it will go to downtown, or it will go to Bay Meadows, it will go to Dale Woods for another campus. So that's the new information that you add on those non-spatial features, which attach to this spatial features. That allows you to do routing. How would you go from point A to point B? And we can search the nearest bus where we are now. And so the digitizing allows us to find further information that we are using every day, like Google Map or some other apps, you name it. So the same way for polyline, we could create the streets. For example, I create a new column that I put the names for the street, because later I could label it so I know which streets is on our campus, near our campus. So the same way, once you digitize the streets, each line, or you can do multi-line to represent one street. You can break into segments, or you can just use one line. You can just digitize one line for one street near our campus. It depends on what you're gonna use. So the object ID and shape here, the geometric shape changing into polyline, and the shape length is being recorded. So once you create the streets the same way, because when we create the feature, we identify as a polyline feature, and the corresponding name, and we can add more columns to record more information about the speed limit, whether it's one-way or two-way driving. The same way we can do for polygons. So polygons here, I digitized the parking lots so that it allows me to draw polygons. The polygons, you can create different shape, or one you can do one shapefile, just record one row, just one feature, or you could do multiple features in one shapefile. Okay, so now the object ID and shape length and the area, it will be automatically recorded by default. So you can create its name so that later I can label the different parking lots. And I even could go in to do more research, create a new column that how many cars I can park in student parking lots 9. So then you can add on more features, or how many handicapped for parking lot 12. That feature will be very useful for you to manage your land puzzle. Okay, so far we cover how to create a feature. Once we have the feature, or people already created a feature for you, you might have to do some edit. So I will go over some of the most common edit tools. So the first one is move. Okay, because the feature are not in there, you can look at the base map or the aerial imagery. You can tell that the feature are not in their correct position. So that we have to move it. To move it, firstly, we just have to click select, and you select the feature you want to move and you drag it there. To move a polygon, so for example, that I want to move for building A, by default, when you click the toolbar here, okay, so you click this, and a construction toolbar will appear in this in the active map. So a yellow dot will appear in the center of the polygon, indicating that this polygon is ready to edit. So that you drag this building polygon A. So you have to match with the outline of the images. Then you click anywhere outside of the polygon, then you drag it again. Continue to drag it to its correct location until it matches this aerial imagery. And on the Edit tab, so once you click the Move button, and this modified features will show up the options you could choose. You can either choose from here or down here to do more of the editing. So that's how previously we see rotate. Sometimes the features may be in its correct location, but you see, it might have to rotate it a little bit. So in this modify pane, we click this rotate button. And once you click the rotate button, the yellow dot, the same way, will appear in this center of this polygon. Additionally, you will see this green circle, which means you can rotate it. So that you just hover your mouse on top of this green circle, and then you click and move and rotate. So the highlight outline, you just highlight it in cyan, then you just have to rotate it to match this satellite image. So by default, so sometimes the features sometimes are represented as simple squares, and then rectangles or circles. But vertices points can be added and modified to reflect the true building shape. Okay, so the vertices. So once we click this vertices, then the vertices will show up. Okay, and you can retype numbers to reposition your reposition your vertices. So this is 2D, so that's why you can see the Z dimension is 0. Okay, then you can change the value to to edit your vertices, or you could use the toolbar. Default, the construction toolbar will show up here. So the first one is you could select the points and you can move around, add a vertices, or you want to delete a vertices, or you want to put some notation there, or you want to validate it, or you want to validate the feature once you're done. Oh, you think, oh, I'm good. Okay, then if not, you want to cancel it, you cross it out. So the two buildings on the campus are drawn as one polygon because they are connected. However, the university architects and facility planners must identify the buildings as separate polygons within a separate record in the attribute. So the split tool will accomplish this task, because it will be a lot easier to manage the buildings. You want to do a lot feature and more attribute table that you want to edit it, and you can add on your records. Trace tool. So the trace tool will help us to, it's very good when you have complicated shapes, such as coastal lines, that the trace tool will pick up those features. Very smart tool to use when you tracing, for example, within these boundaries. You want to trace the whole downtown campus. In this map, that the trace tool will allow us to pick up those features and do a better job, instead of you kind of zooming and going inside to pick it up. That the trace tool will pick up those complicated features. Smooth. Okay, in addition to those added tools, so GIS features can be modified using cartography tools. So one cartography tools is this called smooth polygons. So smooth polygons tool. The smooth polygon tool will allow us to improve the aesthetic or cartography quality of polygons by smoothing it. So that you can see before smoothing and after smoothing. Before, you have those sharp angles that outlines, but here it improves. We cannot see those sharp angles anymore. So the smoothing feature can fix this problem for US Census Bureau, because sometimes they digitize lines and polygons at small scale. And the feature are digitized using just one line or two line segments that do not match the true geography. If you find some extra features, then you can just basically delete the feature. Now we covered some common tools and some of the editing tools, and some of the cartography tools. And how do we do editing? And now we could use other tools to import data, and usually that some machines will do it for us. For example, the ArcGISP, that when you put it, it's called automated digitizing. So the machine will kind of like just scan it for you. So if you have a scan machine, you scan something, it's kind of like just digitize the information for you. The same way is here, that we can use a machine to scan for maps. That a photo image is a raster data. Once you have the raster, you want to scan it and you convert it to vector data. And we also call this as a vectorization, that you transform, you apply the real world coordinates to the raster data, and you can create raster file first, and then you convert it in your software to convert from raster to vector data. So in my previous lab, we used this lab scan to digitize the image. Okay, so the ArcScan has toolbar that will help you to meet your needs. What kind of maps you want to produce and for the resolution you want to choose. Okay, so sometimes we do use the field data to digitize, that we will collect its latitude and longitude records, and then we import it to GIS. And that's how we will use the National Spatial Reference System. That control points will be identified, and surveyors sometimes will have to go out to collect the for the known locations to accurately locate some of the points and boundaries. So here, that's how the some of the benchmark was set up in each city and on different kinds of location, that the NOAA will always will provides those current survey control measurements for you. And survey instruments is being used in the same way that we use GPS receivers to collect those longitude and latitude data to create new vector features. So once we collect all those features, then we will transform it. Okay, so that when we transform it, the adjustments has to be done. Okay, so let's look at this geometric transformation, that the real world coordinate system that we have to transform that digitizer coordinate system that we transform to the real world coordinates. So once you digitize, you get the machine doing the work for you, but we have to use formulas to transform it to register to the digitizer records that match the real world coordinates. So for transform in ArcGIS, for vector data we use spatial adjustment toolbar, and for the raster data we use georeferencing. So before transform and after transform, so what we did, we would just use a tool called displacement link. So let me give you a detailed information that we use CAD files in our use CAD file as an example to show you. So for example, that CAD file we draw, that it contains the layers, but the issue is the scale is different. That once we import this CAD file, we have to export it as a GIS shapefile so that we could edit it. So once we exported this CAD files into shapefile, that we use displacement link. So each side we link on it, and the drawing will contains. So you can see that it contains those groups, and each group, the records will be converted into different polygons. The polylines, of course, it will be recorded, but the polygons that forms each of the segments, that will be recorded. And once we find some error, we can still add it the same way here. Some of the shape it's already being digitized and converted to shapefile, that it will allow us to edit it. So that we use this displacement links to match our buildings in our map. So to summarize, we covered today, we understand why do we have to digitize, and the old way that it's not currently in use that has done, and the new way that we cover some of the common editing tools, and also some tools to do editing, as well as we cover the transforms and adjustment, that how would you store those data in the same coordinate system, and sometimes how would you transform it and adjust it and import it in GIS environment. So this lecture, it kind of was just from the intro and intermediate level. That for intro courses, it's basically just for cartography. How would you make maps? How would you understand map? How would you work with spatial data? For intermediate, geographic information system, that students will, after completing the courses, they will understand how what kind of GIS data format and how would you design it, and the quality of the data, and the spatial environment, and they can perform some of the spatial analysis, how to do geoprocessing, how would you deal with the vector data and raster data. Once they complete the first level of the two courses, they are qualified for a technician position. And the lastly is the advanced geographic information, that students will more focus on the imagery, automation, and more application part. And some of the Python programming will benefit a lot of the students, that they can just write some of the script, that some of the geoprocessing tools they can just automate to run it by writing some of the code. And of course, within the coursework, that in FSCJ, I'm really looking forward to seeing students bring what they learn in construction and different backgrounds to do their interdisciplinary project. And the last level, that we will explore some other GIS open sources, instead of just using the desktop version. That the first two levels is heavily master the ArcGIS desktop, but the last level, that we will explore some of the other features based on what we have, and some of the hopefully we can get some other license to do a better GIS training in studying and training in FSCJ. So my strong background in GIS and my passion, I really enjoy working with the GIS, and the courses that the courses I've been taught for the past years, that I really I really I have a the courses I've been taught in Kansas State University, and my past experiences, that I think the three courses will benefit students, and cooperate with other faculty members, that we can do a better job for the GIS training. Thank you very much.